In this video, we solved problem 8.3.11 from Essentials of Statistics 6th edition by Mario Triola. The problem statement says, park officials make predictions of times to the next eruption of a particular geyser and collect data for the errors in minutes in those predictions. The display from technology available below results from using the prediction errors to test the claim that the mean prediction error is equal to 0. We're asked to comment on the accuracy of the predictions and then use a 0.05 significance level. We're also asked to identify the null and alternative hypotheses, the test statistic, the p-value, and then state the final conclusion that it addresses the original claim. And this time we're not going to do too much computation. We're just going to use this output from technology. So I'm going to click on this little eye here, and then you see what some software gave the people who entered the data. So it says difference at the top is negative 0.524. My guess from context is that that is the mean prediction error from the sample of prediction errors that we have from those park officials' predictions of times to the next geyser eruption. Then we've got a t value, and that is a test statistic when it says observed value. Then we've got an absolute value of t, that's a critical value of t, and there's actually two of them. We'll have plus or minus 1.985. There are 95 degrees of freedom, so that tells us our sample size was 96. They give us a p-value. They're using lowercase p, but we have tended to use capital P for this. For the two-tailed test, we're told that the p-value is less than 0.0001. And the alpha value was the same as the significance level here. It's 0.05. So we've got that. We're going to use that to answer this question. But the first thing we need to do, the first thing that we always do whenever we're conducting a hypothesis test, is identify the null and alternative hypotheses. So let's do that on paper. The first thing we want to do is identify the claim. It says we're testing the claim that the mean prediction error is equal to 0. Now that includes an equals sign, so that's the null hypothesis. If that's not true, we have a not equal to sign. So there are our alternative and null hypotheses. Okay, so the null is that the mean is equal to 0, and the alternative is that it's not equal to 0. Okay, great. And then they want us to identify the test statistic. This really just comes down to reading this display and understanding what it means. This t observed value is negative 7.85. That's our test statistic. Great. Then we want to identify the p-value. Again, we look over here, and it says p-value for a two-tailed test is less than or equal to 0.0001, and they want us to round to 3 decimal places. So if I round to 3 decimal places, it looks like the p-value is 0. It's 0.000. Okay, and then we want to state the final conclusion that addresses the original claim. Okay, now in order to do this, we have to compare the p-value to the alpha value. 0 is clearly less than 0.05. So we're going to say that this test statistic of negative 7.85 is extremely unlikely given that the null hypothesis is true. So we're saying if something that is extremely unlikely given that the null hypothesis is actually true is actually happening, according to the rare event rule, we say maybe that initial assumption that the null hypothesis is true is wrong. So we're going to reject the null hypothesis. And since the null hypothesis was the original claim and we're rejecting it, we'll say there is sufficient evidence to conclude that the original claim that the mean prediction error is 0 is not correct. There is some error in the mean prediction, because the mean prediction error being equal to 0 is incorrect, so there must be some error. Okay, so that's how you do that. We really didn't talk about what all of those things mean. I think I will share a little bit with you about what these expressions mean again. So to do that, I will share my paper with you. Okay, so given our technological output, we can say that the mean is approximately equal to negative 0.524. That is the mean prediction error for our sample. And it looks like our sample must have had 96 different values in it. So if I'm looking at the sampling distribution of the sample means, that's a negative 0.524 over there. And we've got a two-tailed test because this is a not equal to sign. So when we're finding our p-value, we want the probability of getting an x-bar value that is as extreme as this one or more extreme. And we don't care if we're that extreme in the left direction or the right direction. We want both directions. So if this is our x-bar equals negative 0.524, we want the corresponding x-bar over here on the other side. Because this mean is 0, it happens to be, it would be an x-bar of positive 0.524. And then we would have that over there. And the question is, well, what is that area? In order to find that area, we look at the corresponding student or the test statistic t in the student t distribution, which happened to be negative 7.85. So it's not exactly 7.85 standard deviations below the mean, but it's something like that. The standard deviation for student t distribution is a little bit more than 1. But basically we want this area over here and this area over here. That's going to be the p-value. Well, they gave us the p-value. They said that if you found that area in the two tails, where this is t test is this value, and then we'd have another t value over here. That area was less than 0.0001. Of course, this is not to scale. These t values, negative 7.85, is going to be way, way, way out in the tails. Okay, now another way of doing this test would be to look at the critical values. Now they told us in the test, in the output, that the critical values were t equals 1.985 and t equals negative 1.985. So again, this is not to scale. Our critical values of t are closer to that mean. So here is one critical value of t, and here's another critical value of t. This is negative 1.985. This is positive 1.985. And the area over here, the area in two tails that time, is equal to alpha, where alpha equals 0.05. So clearly this p area, that's the probability of getting a t value or a test statistic t as extreme as ours or more extreme than that on either side of the mean. That probability is less than the significance level for our test. So we could have, if we wanted to, just compare this test statistic t to this critical value of t and said that since the absolute value of negative 7.85 is greater than the absolute value of 1.985, this is farther out in the tails, therefore we should reject the null. Or we could do what we did here, where we compared the p-value, which is that probability, to that area alpha. And we said that since that area, the red area, is larger than or smaller than the blue area, which is alpha, then the corresponding test statistic is significantly low, and therefore we should reject the null hypothesis. So that's there for you guys, just so that you understand what it is you're doing and why you're doing it, rather than just following the process. I hope that helps. If not, you can just follow the process like we did at the very beginning of the video to answer the questions that are being asked of you.